So I want to find the double integral of 1 over ln of y. So the first thing I'm going to do is change the order of integration, because right now I don't know how to integrate 1 over natural log of y. So let's look at the graph of what we have. Okay, so the first limit is with respect to y, so it's y equals e to the x and y equals 5. So if we draw these two functions, we get this. So y goes from e to the x to 5. So this is the area we're looking at. And then x goes from 0 to ln of 5. So ln of 5 is over here. It turns out that's where e to the x and 5 intersect, because when I set them equal to each other, y equals e to the x equals y equals 5, I get that x is equal to ln of 5. So this is our region that we're interested in. And at this point, I'm just going to change the order of integration. So instead of doing dy first, let's do dx. So the way to do this is you want to have your first limit to depend on a function, and then the outside limit to be a nice constant. Okay, so first we're doing with respect to x. So think x as horizontal. So like your rectangles would be horizontal. And the lower limit will be the function on the left. So that's the y-axis, right? So the y-axis is x equals 0. And then we're going to stop at the function y equals e to the x. But I'm not going to write e to the x because I want to solve for x, right? My limits are x equals, right? Not y equals. So I'm going to solve for x by taking the natural log of both sides. And so I find that x is equal to ln of y. Okay. Now I want to find the limits in terms of y. So this is going to be easy because all I care about are the constants, right? So what's the lowest value of y? Well, that's clearly 1, right? So if we look at the graph, this is the lowest value. It's y equals 1. And you go all the way up, and what's the maximum value? Well, that's 5. So clearly my integral is going from 1 to 5. And obviously, I don't necessarily recommend to write the y and x equals, but it's good to illustrate what's happening with the graph. Okay, so now we can easily integrate this, because if I integrate 1 over ln of y with respect to x, the 1 over natural log y gets treated as a constant, so I just have the constant times x. So I'll just write it as x over ln of y, and I'm going to plug in from x equals 0 to x equals ln of y, and then I'm going to integrate that from 1 to 5 with respect to y. So okay. Now let's see. I'm going to plug in x equals ln of y first. So I have ln of y over ln of y minus, I'm going to plug in 0 afterwards. But that's just 0, so I don't need this. Ln of y over ln of y is just 1. So what I'm really doing now is integrating 1 over the region 1 to 5. Okay, so yeah, this is just 4. Okay, because you do the antiderivative, plug in 5, plug in 1, and you get 4. Okay, so the final answer to our integral is 4.